Again, sorry this video is so long, but let's go ahead and finish this little movie.
But the other one is neither harm nor help. You might have had a bug hitchhiking on you at some point without knowing it. An example here in the ocean is when remoras hitch a ride on sharks, big rays, or turtles. The remora attaches itself with a disc on its head and then hitch a ride and feed off the food scraps the host animal leave behind. So the sharks are not affected by the remoras being there, but the remoras get a free ride and a free meal. Sounds good to me. So back to our clownfish. Clownfish are protected from predators by living among anemones, and in exchange the clownfish chase away fish and other animals that could harm the anemone. What kind of symbiotic relationship is this? That's right, mutualistic. Okay, but we still have one important question to answer. How can the clownfish be immune to the anemone sting? Well, a clownfish must first get used to its host anemone by developing a protective mucus coating, kind of like when we use sunscreen. And there are two possible explanations for how this happens. The first explanation is that the clownfish secretes its own mucus, which lacks the substance that makes the anemone fire its stinging nematocysts. It's as if the clownfish had a protective force field or invisible cape. And the second explanation is that the clownfish uses mucus produced by the anemone. The unprotected clownfish initially touches the anemone with its fins, even getting stung slightly at first, but over time gains the protective mucus coating. Symbiotic relationships happen everywhere, even in our own bodies. Did you know that every time you eat yogurt, you're actually filling up your digestive tract with symbiotic bacteria? That's right, you become the host for these natural bacteria, and they help you process and digest the food that you eat every day. Alright, so next time you go outside, stop, look around, and see how many symbiotic relationships you can spot around you and record what they are. And remember, never stop exploring your world.
That was a good little video. Okay, so that should be ending up 4.2 for you, or 14.2, so you should be all done with that conceptual understanding. Now going back to 14.1, you can go ahead and cross off two other results of competitive exclusion. I'm not going to ask you about that, so go ahead and X that out. And then lastly, the ecological equivalent is, that's when, if you turn to page, let me see what page. Page 404, it talks about that, and it has the two frogs there. And those two frogs are going to be frogs from the different species, but they live in similar niches. So that's what equilibrium means, ecological equilibrium. So it's just going to be two animals that live in the same habitat or same niche. So that means 4.2 or 4.1 and 4.2 are all done. So the only little bit we have left is 13.4 and 13.3. So go back to our PowerPoint here. Slideshow. So now we're going to be looking at how energy flows. Okay, so the key concepts for this one are to be able to identify the source of energy for life processes and trace and follow the energy through living systems. You'll be able to evaluate the efficiency of energy transfer among organisms in an ecosystem. So first off, producers. These are called autotrophs. And autotrophs are organisms that gather energy from the sun. They are the base of the food chain. Autotrophs produce oxygen, and carbohydrates. Photosynthesis uses energy from the sun. Chemosynthesis uses energy from stored in chemical bonds, and that's performed by bacteria. So on your conceptual understanding for 13.3, you can go ahead and put those both in there. And the similarity between them is that they're both going to use some type of energy. Then we have heterotrophs. And these are going to be, they rely on other organisms for their energy and food supply. Herbivores are going to be something that only eats plants. Carnivores are going to be, they eat animals. Omnivores, like us, both eat plants and animals.
Can you turn up this time, please turn on your TVs for the Pledge of Allegiance, followed by school news.
Interrupted again. Endiatrophids feed on plants and animal remains and other dead matter. So that should have filled out most of the producers and consumers for you. In your producers, you should have autotrophs, because they are going to produce carbohydrates and oxygen. Those are going to be the plants. And then you should have their consumers, which are going to be your heterotrophs. And you can put these down. These are some other names. Then we have our decomposers, which break down organic matter. Chemically, they do not eat the organic matter. So here's the movement of energy through the ecosystem. First, we have solar energy. Well, that's going to be your sun. And that energy is going to go to the autotroph, which is the producer. Then it can go to the herbivore. The herbivore will get eaten by the carnivore. The carnivore will get eaten by the decomposer. And then the nutrients will go back to the producer. Energy only flows in one direction. Nutrients are recycled. So you can see that the energy here is only going to be flow in one direction. So that concludes 13.3. You should be done with that one now. Then let's look at 13.4. We have food chains. And these are steps in which organisms transfer energy by eating or being eaten. They're a collection of many food chains linked together, and it gives a more realistic picture of the total energy flow. Trophic levels are steps in a food chain or a food web. The first level is going to be producers. The second and third are consumers, and each consumer depends on the trophic level below for the energy. So we have our producers right here. This is energy from the sun. It goes to producers, herbivores, carnivores. So on 13.4, it talks about the trophic levels, so make sure you go ahead and put what those are. And you can even give examples there. And you can, a food web shows how energy is transferred. That's another question. And then on the picture there, you have to draw arrows on which is getting consumed. Okay, so only a small amount of energy is transferred to the next trophic level. 10% of it's transferred. So by the time you get to the very, very top where the carnivores are, it's only 0.01% of energy that's transferred from the sun. Most of the energy is used by organisms for movement, metabolism, reproduction, heat loss. Sorry, didn't mean to go so fast. Biomass pyramid shows the potential food available for each trophic level. So there's obviously more food for the giraffes and less giraffes for the lions. Biomass is the total amount of living tissue within a given trophic level. Biomass decreases at each successful level. So that's what I just said. It's going to slowly go down at each level. Pyramid numbers are going to be shown relative numbers of individuals, organisms at each trophic level. And that is the end of our slideshow. If you had problems finding the types of consumers on 13.4, I've already talked about the types of consumers, and those are herbivores, carnivores, omnivores, diatrivores, and decomposers. And you can go back through and find the definitions. Also, that is on in your book as well on page 385. And also, if you need help drawing the arrows, that is actually on the next page as well, which is on 386 for drawing the arrows of your food chain. Have a great day.